Welcome once again, everyone, to Mr. NK's Mobile Learning Unit. Today we're going to be going through 6.2, the Ready, Set, and Go for 6.2. We're going to do the Ready first, then we'll do the Set, then we'll do the Go. For you guys, I do expect you to be able to do the first three problems in Ready. I'll work on the fourth one with you in just a second. I expect you to be able to do the remaining set problems. We'll do one from each section, and then that remaining go problem. Okay, so let's get to it. Let's start off with the ready. So on the ready, it says use the coordinate grid to find the length of each side of the triangles provided. Give answers in exact form and round it to the nearest hundredth. So we want to get the lengths of each side. Most of these are pretty easy, so if I should take a look at this one, I'm like, hey, wait a second, this one is 1, 2, 3, 4, because all I need to do is count it. Oh, length of each side, this one's 4, that one goes down by 4, 5, 6, 7, so that length is 7. And then one of the things that we talked about in class before the break was the Pythagorean theorem. A squared plus b squared equals the hypotenuse squared. So that's what we're going to be using to find the third side of this triangle. Go ahead and just plug that in. A squared plus b squared equals the hypotenuse squared. I'm going to write down the basic form. A squared plus b squared equals the hypotenuse squared. Remember that the hypotenuse is the longest side of the triangle. Hypotenuse is the longest side. That's why I don't say C. It's a little bit easier just to remember that that third side is the longest one, not just the missing one, whenever we're doing this and finding a missing length. Alright, so all we got to do is plug things in. Sides A and B are interchangeable. You can choose which one's A, which one's B, but the hypotenuse is always that longest side. So we can just plug in 7 squared for A squared, 4 squared for B squared, and that equals the hypotenuse squared. 7 squared is 49, and if you needed to use a calculator, go ahead and use one. It's perfectly fine. The only thing is, with a calculator, you're going to get decimals whenever you do a square root, and you don't really want those. So, I'm going to do it all by hand and show you that it's not too difficult to do by hand. The squaring you can do on a calculator if you're having trouble with it, but you can do most of it just by hand. Alright, so we have 49 plus 16 on this side, because 4 squared is 16, equals the hypotenuse squared on this side. And whenever I add 49 and 16, I get to 65. So I get 65 is equal to the hypotenuse squared. I want you guys to take a second and think, what do we need to do to finish solving this? We talked about it at the end of last semester, and that was 3 weeks ago, but think about it for yourself. What would you do to both sides? Okay, give you a second to consider it. All right, so hopefully you've thought of the one right thing to do, and that is take the square root of both sides. The square root and the square are inverse functions. That means they undo one another. Addition undoes subtraction. Multiplication undoes division. And they go back and forth. Squares and square roots work in exactly the same way. So 65 is our square root, and that tells us that the square root of 65 is equal to the hypotenuse. Now notice that the square and the square root canceled each other out, so I don't need to write them anymore. Alright, and that's our hypotenuse for problem number 1, the square root of 65. Okay, now notice that I didn't write any specific decimal value because we don't need to know what the square root of 65 is. That's the answer. That's actually the best way to write the answer, because if we do the decimal, it's going to be a really long decimal value, which is why I don't want you guys to focus on using a calculator to do the square root. All right, take one more second, just take a look at that, and apply the same idea to the other problems here. Real quick, before we move on, if I was here, I would have you guys work on number 4 yourselves, but I'm going to help you out a little bit with number 4 in this big triangle. So take a look at this large triangle, and I'm calling it large because it is bigger than the 2 smaller triangles that are inside of it. Okay, so we want to look at that big triangle and find out the lengths of all 3 sides. The length of the bottom is pretty simple. It's 4. You can see that pretty nicely. But what's the length of this side and this side? Well, the first thing we might notice is we can't exactly tell what that length is. So what we can do is make a smaller triangle. Hence me calling it a larger triangle, and we got these smaller triangles inside it. Notice this one goes over 2 and up 2. In other words, this small triangle has our A and B as 2 and 2. So with the small triangle, we can go ahead and do a squared plus b squared equals the hypotenuse squared, and those are each 2. 2 squared plus 2 squared equals the hypotenuse squared. Okay, and once we've got that, we can get our hypotenuse. Now I want you guys to use that to help you to solve the rest of the problem, okay? So take a few minutes and work on the rest of the problem. And of course, with this video, you can rewind or, pause and everything like that. So don't hesitate to do that. All right, let's move on. I'm going to show you how to do the problems on the set homework. Okay, so let's take a look. The big topic for the set homework is always connected to the topic of our task. And if you remember our task yesterday, it was to graph, or not to graph, but to rotate triangles so that you get perpendicular lines, and to see how you can get a perpendicular line all the time. So this deals with that, but it also deals with parallel lines. So we've got this nice line here, and we want to graph a line parallel to that given line. And then we're going to write the equations of the given line and the new line. We'll talk about those equations in just a second. But let's take a look at our line right there. Nice little line, happy line. Okay, I'm going to pick something that's parallel to it, and you know what? I'm just going to take this line, and I am going to go up 3. 1, 2, 3. Okay, so anywhere on the line, I can just make sure I go up 3, because I want my new line to be 3 above it. Now I have 2 coordinates for my new line, and I'll graph my new line. Boom. Right there. Boom. That's my new line. So I've got 2 parallel lines here. I just need to write their equations, and I'm all set. Well, if you remember from earlier on in last semester, a little bit at the end, but mostly earlier on, in order to graph a line, you needed 2 things, a slope and a point. Okay, and we can graph the equation of a line, or we can write the equation of the line, of a line, using this form. And I'm going to write it right up here so you can see it for all the problems. Y is equal to m times x minus x1 plus y1. Remember, this is where we always said, oh yeah, you got to do the opposite here. Always do the same here. Now, instead of that x1 and y1, I realized that in our class we've been calling it h and k. It's actually something I'm trying to convert people to, because h and k is used in a lot of other things as well, where x1 and y1 is rarely, if ever, used. Alright, so all we need to know is the slope and a point. So that's what we're going to find out for this line. Let's take a look at our original line. Point's real easy. The point's right here. 0 for x, -2 for y. That's pretty nice because I got 0 on the x and then down 2. Very good. For this one, it's 0 on the x and up 1 on the y. So I'm going to write the coordinates of that one as well. 0, 1. Okay. Now, I have a point for each of them. I just need the slope. And for the slope, not too complicated to get. You just need to make a slope triangle. Here we go. And it goes over 1 and up 2. So our slope is equal to the rise over the run. Let me actually write that down. Rise over run. So that's 2 over 1. Okay? So I've got my parallel line. I've got my slope of my original line. I just need the slope of the parallel line. And if I look at my parallel line, hey, wait a second. That's got a slope of 2 over 1 as well. So our m is equal to 2 over 1. That does simplify down to 2. So you could just write the number 2. But if you want to write it as a fraction, I do recommend doing that. You can do that as well. So the equation for a given line, let's zoom out so you can see the whole equation again. I'll do this for our original line. That one's in black, so I'm going to keep my writing in black. Y is equal to 2, that's our slope, parentheses, x, minus h is my x coordinate, which is 0, minus 2, because it's plus k, and k is negative 2, so it would be minus 2. Perfect, that's our original equation. For our other one, it's going to be our green one. Y is equal to 2, same slope, x minus 0, same x coordinate, plus 1. There we go. Now, we don't need to write the x, if you remember, or we don't need to write the parentheses, because this is x minus 0 in both cases. So this can be simplified out, and we could actually write our equations just like this. Y is equal to 2x minus 2. Got rid of the parentheses because we're no longer subtracting by anything. And this one is y is equal to 2x plus 1. You might notice something with each of the parallel lines. Now, I chose to go up 3. This is, for these parallel lines, I want you to choose your own distance. Okay? And I'm going to write it right over here. We shifted up 3. Okay, and that's how I got a parallel line. All right, what about a perpendicular line? Well, let's come on down here. One of the things that we should have learned in the task is that the slopes of parallel or perpendicular lines are opposite reciprocal. So I'm going to write that note right up here. Slopes of, I think I said parallel, slopes of perpendicular lines are opposite reciprocals. Quite a cough. All right. So the slopes of perpendicular lines are opposite reciprocals, which means if I know the slope of my original line, I've got the slope of my perpendicular line. Let's go ahead and see how that works here on number 8. Well, I want to graph my perpendicular line. Unfortunately, I can't graph it right away because unlike parallel lines, which have the same slope, my perpendicular line is going to be a little bit different. So the first thing I want to do is just find out what the slope is. And here it is. My slope goes over 3 and up 1. So our slope is equal to a rise of 1 and a run of 3. So if it goes up 1, it goes over 3. That tells me that the slope of my perpendicular line, I'm going to make that my green one, the slope of my perpendicular line is equal to negative 3 over 1. Okay? It's a reciprocal, it's flipped, and it's got a negative where this one was positive. If this was negative, this would be positive. But since this was positive, that's negative. So they're negative reciprocals. And that tells me that my perpendicular line, exactly where it's going to, or not where it's going to go, but exactly how it's going to go. Now, what's real nice about this is there's a point that's already kind of used here. I'm going to just use that point. And I'm going to use the slope to get another point so I can graph my line. I'm going to go down 3, and I'll use green. I don't want to use green to do that. I'll use a lighter green to do that, actually. Down 3, 1, 2, 3, and then over 1. The down 3 gives us our negative 3, and over 1 is the 1 on the bottom of our fraction. And this gives us our second point. So now that we've got 2 points, we can keep going. Down 3 over 1, down 3 over 1, get some more points on there, and graph our line going through. This is our perpendicular line. And you'll notice that the perpendicular line makes a nice right angle with the original line on all different parts of it. So that is really cool. All right. So let's go ahead and get the equations for these lines. Well, we already have the slopes. That's nice. We just need a point, and luckily for us, that point we already found. Since I used this point, we already got it. Let's just use it. 0, 1. All right. So our original line is black. Let me go ahead and use black to do that. Y is equal to 1/3. That's our slope, times x minus 0, that's our h, plus 1, that's our k. Okay, 1/3 x minus 0 plus 1. I don't need to write that minus 0 in those parentheses, so I can just write it like this. Y is equal to 1/3 x plus 1. Problem solved for that one. Let's go ahead and work on the green line now. So the green line has a slightly different slope, same point though. You might notice that all of this is the point, so the slope is the only thing that changes. So that's all I'm going to do here. I'm going to just write that equation, y is equal to x plus 1, because all that other stuff is just going to be canceled out, and I'm just going to change the slope. And oh wait, I just noticed something. Hey look, that slope is negative 3 over 1, which means it simplifies down to just negative 3. So I can just write y is equal to negative 3x plus 1. Notice how using these tricks just makes things look nicer a lot of the time. And that's one thing that you get used to as you get better and better at math and things like that. You're like, oh, that looks nice. I'm going to do it this way. All right, so this is our set homework. I want you to work on the other 2 problems yourself, and then let's go on to the go. Now, with the go problems, these ones I don't exactly, I'm not exactly need you to be all that invested in them. I just want you to try things out. We're not going to be solving equations so much here. We're going to be solving equations a bit more in the future, though, whenever we get to Module 7. So you do want to be able to solve equations, but it's not that big of a deal. It's far more important that you're able to do this and that you're able to do this, okay? It's not too important for you to solve equations, but I still want you to try it out. All right, so on these problems, we're going to solve for our value that's listed. Here we've got this equation, and it says solve for x. So we want to get the x by itself. Notice how x is in 2 places. Before we get x by itself, we need to get those x's ready to be put together. So that's what we're going to do first. And my first step is I'm going to take that 3, and I'm going to multiply it by the x and by the 2. This is called distributing. So I got to distribute that 3. And I end up with 3x minus 6 equals 5x plus 8. Okay? So that's the same equation as up here, just without the parentheses. I distributed it to get rid of those parentheses. And now I want to get the x's together. So to get the x's together, I just got to do one simple thing. I got to move them over. So I could move the 5x to the other side, but then I'm going to have to deal with negative numbers because 5 is bigger than 3. If I move the 3x over, I'm not going to have to deal with negative numbers, so that's a little bit easier choice. So I'm going to subtract 3x from both sides. Okay, and whenever I do that, I get this equation. First, let me cross this out, and the x's don't disappear. This is kind of like saying I've got 5 oranges and I get rid of 3 of them. The oranges don't disappear. You don't just have a random number after you get rid of 3 oranges. You still have oranges, you just have less. 5x minus 3x would be 2x plus 8 at the very end, because we didn't do anything to that 8. Well, this looks pretty nice. We want to solve for x, and this is where that do and undo chart comes in. If you want to just use that, you could. You don't need to, but it's definitely a good idea. You might remember this from last semester. Do and undo. So if I take a look at x, I can say the things that were done to it. This x was multiplied by 2, then we add 8. So that's our do list. Times 2, and then plus 8. So to undo that, we would go in reverse order and undo each step. Minus 8 and divide by 2. Okay, so that's our do and undo. Let's go ahead and go through those steps. So we're going to subtract 8 from both sides. That'll get rid of that 8. And we get negative 14 is equal to 2x. Oh, cool. And now we just got to divide by 2. Divide both sides by 2. Hey, look at that. 14 divided by 2 is 7. So this is going to be a negative. That negative doesn't disappear. And 14 divided by 2 is 7. And that equals x. Those 2's will cancel out, so we don't have to worry about that. And now we answered our question. We solved for x. Okay? So that's what you want to do for each of these assignments. The ready, the set, and the go. Again, this is homework. I do not care so much about you doing it right. I just care that you're thoughtful and that whenever I get back, I can see your ideas clearly. So, even if you make mistakes, I don't care so much about that. I care that you're doing it right. But if you go over to the side and you draw an octopus and you're like, I tried, that's not trying. I want you to actually try to answer these to the best of your ability. Okay? I do hope I'll be able to see you guys early next week. If not, then I will either see you then I'll probably see you on Thursday of next week. But I hope you have a wonderful 3-day weekend. I'm going to spend mine stuck at home. So have a good weekend, and I'll talk to you later.